The health professional using telepsychiatry must master the basic notions of how computer networks work from a software and hardware point of view. The health professional using telepsychiatry must master the basic notions of how computer networks work from a software and hardware point of view. The health professional using telepsychiatry must master the basic notions of how computer networks work from a software and hardware point of view. The OSI model is a reference model for communication between computer systems and can be used to understand the technological infrastructure required to implement telepsychiatry. The OSI model is short for Open Systems Interconnection and is a conceptual framework that defines how network systems communicate and send data from a sender to a receiver. The OSI model is used to describe each component of data communication in order to establish rules and standards for applications and network infrastructure. The OSI model contains 7 layers that stack conceptually from the bottom to the top. These layers are physical, data link, network, transport, session, presentation, application. The OSI model was established in 1984 to create a standard for network design and equipment manufacturing. Without the OSI model, there would be no standard way to design the infrastructure and protocols used for communication, making it more difficult for administrators to install new equipment and integrate it with networks other than their own. With these standards, administrators can design their own infrastructure, but the equipment can still communicate with others in a universal way. When the OSI model was established, the 7 layers were defined to follow standard principles. Each layer has a distinct level of abstraction. Each layer performs a defined function. The layers are defined to create standardized international protocols. Layers facilitate communication between the infrastructure and the applications. Each layer corresponds to a specific function in network communication. Standardizing communication across a network, including external networks, the cloud, for example, facilitates communication regardless of where data is sent or received. The OSI model allows manufacturers to create their own protocols and equipment standards while allowing interconnection with other manufacturers. Another advantage of the OSI model is that it is easy to troubleshoot. When a network component fails or an application does not communicate with the network, the OSI model helps administrators determine the failed layer and component. Standardization of modern technology makes it easier to build, manufacture, troubleshoot and design new technologies in the future. Open Systems Interconnection model is broken down into layers. Each layer has a specific function and communicates and works with the layers below and above. The OSI model is conceptual, but its design allows for both physical and virtual communication on a network. We will start with layer 7, which is the highest layer in the stack. Layer 7 is the application layer. Layer 7 is familiar to most people because it communicates directly with the user. An application running on a device may communicate with other OSI layers, but the interface operates on layer 7. For example, the professional using software to communicate with when a message is received on the client's software, it is the application layer that presents it to the patient. Layer 6 is the presentation layer. We mentioned that the application layer displays information to users, but the presentation layer of the OSI model is the one that prepares the data so that it can be displayed to the user. For example, communication with a web server via HTTPS uses encrypted information. The presentation layer is responsible for encoding and decoding the information so that it can be displayed in clear text. Layer 5 is the session layer. To communicate between two devices, An application must first create a session, which is unique to the user and identifies him or her to the remote server. The session must be open long enough for data to be transferred, but it must be closed once the transfer is complete. When large amounts of data are transferred, the session is responsible for ensuring that the entire file is transferred and that retransmission is established if the data is incomplete. Layer 4 is the transport layer. The transport layer is responsible for taking data and breaking it down into smaller pieces. When data is transferred over a network, it is not transferred in a single packet. To make transfers more efficient and faster, the transport layer breaks the data into smaller segments. These smaller segments contain header information that can be reassembled on the target device. Layer 3 is the network layer. The network layer is responsible for breaking down the data on the sender's device and reassembling it on the receiver's device when the transmission is over two different networks. The network layer is responsible for creating small packets of data that are routed to their destination and then reconstructed on the recipient's device. Layer 2 is the data link layer. The network layer facilitates communication between different networks, but the data link layer is responsible for transferring information over the same network. The data link layer transforms packets received from the network layer into frames. Like the network layer, the data link layer is responsible for error and flow control to ensure successful transmission. Layer 1 is the physical layer. As its name implies, the physical layer is responsible for the equipment that facilitates the transfer of data, such as the cables and routers installed on the network. This layer is one of the aspects of network transmission where standards are essential. Without standards, transmission between devices from different manufacturers is impossible. Data flows from layer 7 to layer 1 from the sender, and then from layer 1 to layer 7 on the receiving device. The simplest example of communication flow through the OSI model is an email application.